Good morning, good afternoon, welcome. This will be uh, um, a meeting where we will want to share some knowledge and some experience. My name is Jose Liendo. I was working in a project where we were working related to a data architect patterns, and I want to share my experience as a data engineer using as well the GPT-Plus tool. So this is the online tech talk where we are sharing this type of knowledge and some discoveries or experience, as I said, related to some work that we are doing, in special to the data engineering. So please, we have a channel in YouTube where we are uploading all these recordings. So if you like this video, or if you want to look to other kind of contents that we are sharing, please go there, and if you like, please give us a like. So for today, I want to share some notes that I took during this month around the project where we need to resolve some issue for one of our customers, where we implemented different type of some schema and some data flow, where we were using some AWS services. So we were using Glue Stream jobs, and in that process, we were inferring some data schemas, and as well we were translating an JSON schema into a normalized tables in an SQL database. Then we were using Redshift, and we were using some patterns to avoid duplicated values there. And as well, we were dealing with compressed data in order to be more performant, to send less traffic and use as well less space, and also the project will have a minor billing. So before going through this slide where we are showing some diagram that we created, I want to show this one. This slide. This is more or less the problem that, or the issue that we were around where we were working. So we received a JSON file. On the left side, we have a typical JSON schema that it has a nested structure and schema. In this case, we have as well nested components, nested elements, and we want to translate this data through relational schema into a relational database, and which is Redshift. And we were using an ETL in order to make this transformation. So the input will be some JSON files, and the output will be relational data in a relational database. So in order to make this, we want to infer the schema of a JSON file, and then to translate it to this kind of relational model. So around the data engineering process, we were using this ETL, which is extract, transforms, and load data to a different source. In this case, we are taking JSON data, and then we do some transformation, and lastly, we are loading the data through Redshift. So regarding and around this process, we were using AWS services, and as well we were using latest features and functionalities, and we want to use everything that we want. We have available in AWS, so we were using ChatGPT as well to retrieve all the functionalities that we can use. So during this experience, we were having, or I was having different type of results. First, I was using ChatGPT Plus, which is the version number 4 and the paid account. and I was gathering data around what this service does and can do related to the problem that we want to solve. So what I show in the previous slide, it's around this service with the name GlueStream Job that is receiving files through an input. The input is behind this Lambda, and finally we want to put the data into a Redshift serverless database. So to make this process, we were doing a couple of things. First, we were inferring the schema. Then we were translating that JSON schema to relational table, like isolated tables that then we want to join, and finally to put it here in Redshift. So to make this process, we were using ChatGPT, and we discovered that ChatGPT was giving like a very good insight that it was out of date. So to make these two or three things that I mentioned related to infer the schema and to create these relational tables, it wasn't accurate to give the answer that we finally proposed to this client. So about this, I want to say two things. First, or three things. First is a great tool. It has out-of-date data because it has data until 2021, and the features that we are using here, and they are created or available through 2022. So that was one of the discoveries during this month. So what I want to do here is to give you some gifts. I said that they are the discoveries that we made related to these features. So we were using, I was using ChatGPT 4. I go into OpenAI and click here into try GPT-Plus, and I was using the model GPT-4, and that it has the best performance in the reasoning, and it's not so speed, but it has like the better performance. And I was asking here how can infer a schema, how to create relational data from a JSON content using PySpark, which is the language that we are using mainly in Glue, in a Glue service. So it give like a very good context, but it's not at all updated or accurate. So I list here some tips that I discover here around these services, and I want to share with you. First, I put here Kinesis data stream, and okay. So before talk about this, we were receiving data from a Lambda, and we are receiving a JSON file, and we are putting this data into a Kinesis data stream, and then we connect it through a Glue stream job. So the reason that we choose these two types of service is because we want to process this data in near real time. So because of that, we choose the Kinesis data stream and as well the Glue stream job. It is not a traditional Glue job. It is a stream job that it's processing the data in real time. So in order to work around this, the first thing is that we have a main limitation that the Kinesis stream works with records, and this record has 1 megabyte at most. And in case we want to handle like bigger amount of that data, we need to split the data and regroup But in this case, we want to achieve like to handle a small piece of data and then process it immediately in Glue job. So we were sending a small record of 1 megabyte to send data in real time, and as well this allow us to have multiple consumers. It's similar to Even Bridge in this case, but the difference is like we are sending the data through services. In this case, we are sending the data, the stream data in Kinesis. And then regarding the Glue stream job, what we are doing is to have a Glue job that is constantly running and listening to this stream and processing data. So because of this, the services is expensive, but it's very accurate to process data in real time. Then we are using PySpark, as I mentioned, in the Glue service to create our scripts that does the transformation. And what PySpark offer, if I did a previous conversation related to the Glue services, and then we have two main languages that we can use. We can use PySpark, which is a Python API to use Spark, and then we can use Ray to use Python as well using Spark. If you are not familiar with this language, the main concept here is that Glue, what it does is to distribute the work to be done in several workers. It uses the divide and conquer strategy to split the work in different workers, in different threads, and then compute the result pretty soon, comparing this to a mono-thread processing. And then because we are using this wrapper, this Python API for Spark, this language offers a method named relationalize. What it does is to receive a JSON schema and process and split the data in relational tables out of the box, and it does a pretty good job doing this task. Then we were discovering two things. We were working in records from 1 megabyte, so we want to improve the performance to send the traffic, the data through Kinesis. So we were working with compressed data. And what we achieve here is to send 10 times more of data with the same size. So Glue, what it does as a service, as an AWS service, is to work with some algorithms, compression algorithms like gzip, and there are a little of 3 or 4 more algorithms that they understand out of the box. So in this case, for example, we can, instead of processing 1 megabyte of a JSON file, we can send 10 megabytes of a JSON file compressed in gzip, and that as well will be something that the Glue jobs can work with without doing anything. They have a feature that is, the name is auto uncompress, and that they understand the content type of the file, and that's the transformation from a list of the final algorithms. So we were using gzip. But we as well, related to this topic, we were receiving data through an API gateway, and we discovered that sometimes when we are receiving data as a payload, we need to encode the data as in base64, and the Glue jobs, then we need to avoid to encode the data in base64. If we are sending data from an API gateway through a Glue job, we need to decode the data in base64 and then compress in gzips and send it directly to the glue job. That is another tip that we discover. We have some issue related to this. This is the auto decompression feature that I mentioned. This was released in 2022, and the AW Glue Service ETL supports decompression. And here we have bzips, gzips, snappy, and so on for these other formats. So they understand two layers. The first is if the file is compressed or not in these formats: bzips, gzips, snappy, and so on. And then related to the compressed compressed content, they understand Avro, JSON, CSV. So if we are, we can join, we can choose any of these combinations, and the glue stream job will just understand how to process the data. Then as well, we during this process to store data in Redshift, we arrive to a position where we need to update data. If we come back to our problem at the beginning, we were receiving files. In this case, we were receiving, or we plan to receive 500,000 of files, and we want to put all this data in different tables, and we want to do it in a way that this data doesn't show duplicated data. So we were getting different type of schema from a JSON files, understanding some concepts, and then translating to a given model. So once we are doing this, let's say that we post the same file into all this engine, and the information arrived to Redshift. We want to avoid duplicated data. So today Redshift doesn't have a feature to do this process, because will depend on the data, of course, and how we know if some data is duplicated. So in order to make that we need to define the entities that we are working, for example, persons, company, and we need to define the let's say a kind of primary keys that defines the uniqueness of some entity. So for example, for a name, we can say that, well, a person is defined by his name, by his surname, or by his document. And with those three coordinates, we can say that the person is unique or not. So using that approach of those primary key, these unique together entries and fields, we were using a pattern named Upsert in Redshift, which is this one. This is a strategy that AWS recommends to use because of this process that needs to have some human support until now, and I found it pretty interesting and elegant. So this is a piece of code written in Python, where the more important thing is how we are storing data. This strategy, what it does is to use a temporary table before arriving to our table. So in this case, what we are doing is a unique transaction, or where we are using preconditions and post conditions. So for example, here, what we are doing, well, maybe we need to change some names here, but here what we are doing is we have data. Usually we have data in frames, in data frames, but it doesn't matter go in that direction. We have the data in frames, and then we have some database connection. In this case, we were working with Redshift, so we need to define the connection to Redshift because we are in a view job and want to point to a database. We have some temporal directory, and then we have some connection options. These connection options will point to a database, to a table, and will have preconditions and post conditions. So in particular, if we come back to the example of the persons table, what we will do is to insert the data instead to insert the data into a person table, we will use an intermediate table. This table will have the name that's person staging. So what we'll do is to first go to the pre-actions, and when we do these actions, what we'll do is to go to this person staging table, and we will drop if exists the table. Then we will create it again, and we will create it from the schema from the table that we want to insert the data. In this case, from the person. So first of all, what we are doing is to clone the schema from the person table into a person station table in order to have all the fields that we want to have. Then what we are doing is to insert all the data into the person staging table, right? We receive data from the JSON file, we translate it to a data frame and insert it into the person staging table. And once we have that, which in this action, when we are inserting into the person staging table, we have the post actions. And in the post actions, what we'll do is to delete all the information that we have here in the person staging table, but we will look for all the data that we have in the person staging table, but in the target table. We will delete all the information, and we will insert then all the new values from the staging table to the target table. So first here we are deleting data from the target table using the staging table, where we are using some fields. The fields will be in the example that we are using the first name, the last name, to look for the uniqueness of the person. But we will be inserting all the new data. For example, all the new data could be if the person changed, for example, his phone address or his email or something like that. We will deleting everything that we want from that person and inserting all the data that we are receiving. And finally, we will delete the person staging table. And all this process, it's a merge strategy. It has some limitation because we need to do, in this case, a put. We are rewriting the data that we are receiving table, but doing this pre and post condition. So I found it interesting, at least to share with you. And then, well, these were the main discoveries that we found that were pretty useful in this flow, in this architecture. So maybe let me know if we have any question. Of course, we have questions, but this is what I want to show today.
This is
yes.
Awesome.
You like it?
Yeah. Hello, Jose. Well, thanks for the presentation. I have a couple of questions. I will start with the first one. So basically, you were using ChatGPT and you mentioned that it was not accurate related to the Amazon services, right? So I assume that ChatGPT provide you some insights or directions, but not the updated ones because the Amazon services update the services, right? So I want to understand if ChatGPT provide you those tips or insights, or you ask it how I can do an app sort on Redshift because it's not available, and ChatGPT provide you the insights, and then you finally solve your issues Googling on internet because the Amazon services were updated. So just to understand how do you use it, ChatGPT? It's just to talk to a person and chat to and trying to understand or make it, or maybe you made some logical question, right? How I can solve this, or how I can manage like 500,000 transactions, and maybe ChatGPT propose, okay, you can compress the data. So I just want to understand if you made those kind of logical question and ChatGPT provides some suggestion or insights, right?
Yes, the, the process that I did is to first interact with ChatGPT. They give us the basic things related to the service and what the service does, or they what ChatGPT does is to give the logical scripts that we can use, and as well they offer an approach that we can use for to solve these same problems, that they are don't update it.
Yes.
So what I did is to in YouTube, where I found some specific channels that talk about that data engineering and talk about this all this kind of functionality that they are pretty awesome. And what I learned here is that ChatGPT particular things related to the language or to the capabilities of some services, that to have like the more updated features, I need to like a human being that analyze and give guidance about how to solve something in the same way that we are doing here today, this OTT. I think one of the conclusions here related to this particular scenario is like what we are doing here to show and to bring all these discoveries and ideas. It's something that at least today this tool doesn't provide, because it's not updated and doesn't link like different concepts to, for example, give to some customer custom solution to their problem. So a lot, but I discovered that it has, I think that the more important thing to consider here is that it doesn't have updated data. That makes a big difference. And then it can understand and to keep a conversation, to learn like corrections in the conversation, that because I want to use PySpark and I am receiving a JSON file and I want to compress, we can have a conversation, but but it's what I found is like it is limited what they have in the current knowledge base. So I guess like in the near future, where we can insert like more data, for example, like this OTT or some we can put new data into this model, it will be very powerful and more specific to some topic. So we are in front of a great tool. It has some limitations, and then the work that we are doing here, I think it's very valuable. The process to share this kind of knowledge, these tips. I found it like it's like we are doing a good job sharing this kind of information, because ChatGPT is great, but it has these limitations.
Awesome, thanks. Yeah, I think it's like all the information and the insights are really valuable for future projects and working on data architecture solutions. So yeah, thanks. And I have another question related to GPT, kind of the focus of this meeting, or maybe a bit. So is there any difference between the paid version and the free version? Besides that, I see that it allows you to select the model that you can use it. But if you paid, it allows you to select a newer or more updated data model, the GPT-4, or did you find any difference between the paid and the free version?
Yes, it has a limit about the availability of the service and the amount of questions that you can do. And as well, I think the ChatGPT-4, I'm not sure if it's completely available in the free account. Maybe Einstein, you have a more accurate.
Sure. Yeah, ChatGPT-4. Hi guys. ChatGPT-4 is also more eloquent, and it's trained against more features, so it's considered more advanced in its responses. But the cutoff, even the cutoff for ChatGPT-4, I think it's somewhere in 2021. That being said, there's also capabilities that ChatGPT-4 has that 3.5 does not have, such as the ability to analyze images.
Yes.
That's one. So there are some differences. You can, for example, upload an image to and provide a URL or a link to ChatGPT, and ChatGPT will look into that link and analyze the image for you. Or it can analyze, for example, Swagger files or YAML files. It can even analyze data structure, table structures to determine how normalized your tables are.
Oh, nice. Yeah, I have the free version. I asked basically which GPT version are you, and it replied, I'm the 3.5 version. So the free is using the 3.5, and if you pay, you are allowed to use the GPT-4. Okay.
Yeah. Good. See, for example, on the screen, it's more concise. The reasoning is superior. It's slower though, but yeah. And soon they're going to come out with other features with GPT-5, which is making a lot of noise right now. So. Anyways, I won't ramble. You can tell I'm passionate about the subject. So
nice. Yeah. I entered on YouTube, and it's like I getting crazy content about GPT and yeah, a lot of stuff going around.
What is amazing is like the tool is able to create a completely script. We can ask to create some algorithm, and they will just do it. But the current limitation that we face here is that it is not updated. So once they solve that problem, we will be in a very different scenario. Or if we can create a custom model where we can teach to this model about some topics that they are useful to us, and it's a very, very convenient tool. Well, so guys, this was this OTT. We want to talk about this ChatGPT and what it does, or the experience using this ChatGPT during this process, and as well we want to share these tips that we discovered. So I hope it was interesting. So let's see us on the next meeting. Bye-bye.
Thank you. Have a good weekend, everyone. Good stuff.
Thank you. Weekend. Bye-bye.
Bye.